How do you find the sum of a geometric series? How do you find the sum of 0.01 plus 0.02 plus 0.04? And on until you're adding up 10.24. Well, the first thing is identify it as a geometric sequence of numbers. And because you're adding them all together, it's a geometric series. There's a special formula for that. S is the sum, A is the first term, R is the common ratio, that's how much you're going, like what you're multiplying by to get to the next term, and N is the number of terms that you're adding up together. Well, unfortunately, we don't know how many terms there are. We need to figure out what N is for this final number. We have to use the formula for a geometric sequence. Do you remember this? Tn is AR to the n minus 1. This is a term, first term, common ratio, and how, like, the index of whatever term you plugged in here. If we want to find n for 10.24, we're plugging in 10.24 for Tn. We plug in our first number for A, because it's our initial, our first term. There we go. We're doubling each time. See, double, double. And we need to solve for n. How do you solve for n here? Well, the first thing is divide out the number in front of your exponential. When I divide that, I get 1024. And then I either have to guess and check or use a special little log trick. I'm going to guess it that the exponent is 10. Let's see. 2 to the power of 10 is 1024. So if 1024 is 2 to the power of this, then this must be 10. Look, my exponent is 10. And to undo the subtraction of 1, turns out n is 11. I'm summing 11 terms here. Once you do that, you can plug into this formula. The sum of the first 11 terms is the first term times the common ratio to the power of n, 11 terms, minus 1. All over the common ratio minus 1. How do you do this in your calculator? Just make sure that your denominator is in brackets. Check it. Let's see if I can point this so you can see it again. 0.01 times, in brackets, 2 to the power of 11 minus 1 divided by, and then my denominator in brackets, 2 minus 1. I get 20.47. So, the sum of all these terms together, according to the formula, is 20.47. Personally verify that that's true. Hopefully, you'll be able to do this yourself. The trick is to find the n that corresponds to your final term and use that in the formula for a geometric series. Best of luck.